pale albino rats. What do you think is the reason for the difference in their behavior? The animal on the left is hungry. The one on the right, with the food in his cage, is satiated. How will this difference in drive affect their... In order to see whether the difference in drive will produce a difference in learning, we're going to use an apparatus with two identical compartments. One for the animal that is very hungry, and another for the animal that is not hungry. At the outside end of each compartment is a food delivery apparatus. This consists of a stirrup-shaped bar placed above a food dish. Pressing the bar delivers a small pellet of food into the dish immediately below. We will now put the hungry and the satiated animals into the apparatus and watch for differences in learning. After being put in an unfamiliar environment, both animals are active. But the hungry animal is somewhat more active. The hungry animal remains active, but as the satiated one becomes adapted to the new environment, he settles down and becomes inactive. Watch the wide variety of responses which the hungry animal makes. Since each of these responses occurs without reward, it is soon displaced by a new response. The behavior is variable. What responses do you think the other rat is making? The satiated rat is inactive. But even if he had hit the bar and got a pellet, food would not be a reward without the drive of hunger. The hungry rat is active. He stands up near the bar, but just misses it. The correct response of pressing the bar cannot be rewarded and learned until it occurs. He approaches the food device, stands up near the bar, presses it, but since he does not see the pellet and the food cup, he is not rewarded. Now he finds the pellet and is rewarded for approaching the food cup. From now on, he confines more of his activity to the region of the food dish. At last he hits the bar and gets an immediate reward. Has he learned? Will it take him as long to press the bar the next time? Although the animal still makes quite a few irrelevant responses, he presses the bar much sooner the second time. The occurrence of a single reward has strengthened the tendency to make the response of pressing the bar. Notice that the rat performs exactly the same response which was rewarded. In the next trial, you will see that coming up to the bar from a slightly different angle, the rat makes a new response. He goes around the side of the stirrup instead of down through it. He goes back to his old response. He still makes a few irrelevant responses. Watch him go around the side of the bar again. This response gradually wins out because it is rewarded the fastest and with the least effort. On the next trial, you'll see that the animal starts down to the food dish before he has pressed the bar hard enough to get a pellet. He makes several anticipatory errors which are not rewarded and regresses to his old response of diving through the stirrup. These anticipatory errors occur for a number of trials and then are gradually eliminated. After several more trials, which are not shown in the picture, the hungry animal has eliminated irrelevant responses. He has learned to press the bar efficiently. Now, what do you think the satiated animal has learned to do? With this device, we can put a mild electric shock on the grid on which the rat stands. The shock is adjusted to be annoying, but not painful. Shock is on. Shock is off. Pressing the stirrup bar turns off the shock. Although the shock is not strong, you will see that it supplies enough drive to produce a radical change in the behavior of the satiated rat. He hits the bar, the shock goes off, and he's rewarded. He hits the bar and is rewarded again. After a few more trials, which are not shown in the picture, he has learned to press the bar quickly as soon as the shock goes on. In fact, when a drive is supplied, the satiated animal learns even more rapidly than the hungry one did. This is because the drive produced by electric shock is stronger than hunger. It makes the rat more active and can be reduced more quickly and completely. We have demonstrated that the satiated animal is not innately stupid or lazy. All he needs is a little motivation. Again, a mild electric shock can be administered through the grid on the floor of the apparatus. This time, it can only be turned off by rotating a wheel. As soon as the wheel is moved, the shock goes off and stays off till the next trial. Just as in the preceding demonstration, the satiated animal starts responding as soon as a drive is supplied. The end of the punishment reinforces the response. The behavior of the animal has been radically changed by this training. After training of the type you have seen, this animal has learned to bite a rubber tube as soon as the shock goes on. When he starts biting, the experimenter turns off the shock. Responding to another animal by striking him can also be learned. These animals have already been trained. The experimenter turns off the shock as soon as they strike each other. You have seen the role of drive in producing activity. The hungry animal is active. The satiated one is not. The hungry animal learns the response, which is rewarded by the food that reduces his hunger drive. The satiated animal is inactive. Without hunger, food would not be a reward, even if he got it. Therefore, he does not learn. But when a drive is supplied by giving him a mild electric shock, he suddenly starts responding and quickly learns the response he was making when the shock went off. Motivation and reward are crucial factors in learning. A motivated animal will learn any response which occurs and is promptly followed by a reduction in the strength of the drive. In this way, motivation and reward control learning.